All right, so I'm going to keep going with the chemical mixture problems and see if we have any weird situations that pop up with the next three questions here. So read it, annotate it, you know the drill. Chemist has 400 milliliters of a solution that is 40% salt. How much of an 80% salt solution should be added to obtain 60% salt? All right, I'm going to do my usual. This is what I am starting with. We're going to add something to it to create some form of a final product. So what are we starting with? We are starting with a 40% salt solution. We are adding an 80% salt solution to create a 60% salt solution. Okay, so let's see what we've got here. We are starting with 400 milliliters. That is 40%. How much of the 80%? No idea. And so that's going to create 400 plus X for our final quantity. Once this information is filled into this, the equation just falls right out of it, which is pretty nice. So let's see, 40 times 400 plus 80 times X is equal to 60 times 400 plus X. All right, a little bit of calculator-friendly help here. Let's see, 16,000 plus 80x. I believe that's 24,000, but I want to double check. It is. So 24,000 plus 60x. Okay. I'm going to subtract 60x from both sides, so that's 20x. I'm going to subtract 16,000 from both sides, so that's 8,000. Divide by 20, so x is equal to 400. So 400 in this case is our x value, which represents the quantity, how much of the 80% salt solution, so 400 milliliters. Okay. So problem number 4 is all done. I'm going to go ahead and roll on down to number 5. All right, so Jen has 200 liters, that is 40% oil. How much of the solution must be poured off and replaced with pure oil to get a solution that is 45% oil? All right, so we've got a lot of moving parts in this one. Okay. So you've got what you're starting with. You are going to pour off some of it, which means subtraction. You are going to then replace that to create your final solution. So this is your start. This is pour off. This is replace. That's horrible looking. Let me try that again. That's replace. And this is your final creation, your final solution that you're trying to make. Okay. So let's start filling in some percentages here. What are you starting with? You are starting with 40% oil. If you are starting with 40% oil, that solution that you pour off would still have 40% oil. Okay? You are replacing with pure oil. Well, pure oil is 100% oil. There's nothing else in it. It is pure. And you are going to get a solution that is 45% oil. Okay, so there are all my percentages. Let's fill in some quantities now. All right, Jen has 200 liters. Okay, how much is she going to pour off? No idea. All right, X it is. But if I pour this quantity off and replace it, the amount that I poured off is exactly how much I'm going to put in. It's called replacement. Okay? So if we go across here and we're just looking at our quantities, we have 200 minus X plus X. Well, minus X plus X means those are gone. They're going to cancel down to nothing. And what's left is the 200 that you started with. All right? By pouring something off and replacing it, you're basically back at the same position you started from. So the 200 liters You're still going to have 200 liters, but you've changed the quantities by the percentage. Okay, so that's where you want to pay attention to that part of it. This equation still falls out just like the other ones did. So 40 times 200 minus 40 times x plus 100x is equal to 45 times 200. All right, so double checking my math. That's 8,000. I'm just going to go ahead and combine these two like terms. Negative 40x plus 100x would be positive 60x. Let's see, 45 times 200, there's 9,000. So let's see, 60x, I'm going to subtract. That's 1,000 on both sides. Divided by 60. So x is equal to, that is the wrong answer. I divided the wrong number by a 60 there. Ooh, that looks a little bit better. 16.67 liters. As a fraction in this case, it's not terribly useful when we're talking about actual quantities, but the fractional value, the exact value here is 50 over 3. So if you gave me that, that's okay too. Whoops. I don't know why that just popped up. Sorry about that. All right. Okay, so let's go to the last one here. Number 6. Mr. Kravitz is mixing his magic potion. He starts with 50 milliliters, that is 30% chocolate. He wants 100 milliliters at 40% chocolate when he finishes. How much chocolate does he need to mix at 10% chocolate? Okay, so let's start talking. We are going to start with something. We are going to mix in some quantity to end up with a quantity. Okay. Percentages. He is starting with 30% chocolate. He wants to end with 40% chocolate. How much chocolate does he need to mix at 10% chocolate? And at this point, I am going to stop writing down anything and tell you that this is not possible. Okay? Here's one of the things that you need to know logic-wise about chemical mixture problems. If you have a 30% solution and you are mixing it with a 10% solution, your finished product will be between these two. It's not possible to take a 30% solution and add a 10% solution and make it more concentrated. It's just not going to happen. All right. So in this particular problem, this is not possible. I want to keep going with it to see if I can show you mathematically where it would fall apart. Okay. So he's going to start with a 50 milliliter solution. He wants 100 milliliters when he's finished, which means this would have to be 50 as well. 50 plus 50 is 100. Okay. So let's check the math on this. So if I take 30 times 50 plus 10 times 50, is that the same thing as 40 times 100? I have no idea, but I'm going to bet no. All right, 30 times 50 is 1,500. Okay, plus 10 times 50 is 500. And 40 times 100 is, I'm pretty sure, 4,000. It is. All right, so 4,000 here. Yeah, I'm getting a really nice equation here that says 2,000 is equal to 4,000. And I'm pretty sure everybody who's watching this video knows that this is not true. Okay, so be careful with some of these. All right, they're not always going to work. And again, the logic on that, whatever percent you start with and whatever percent you're adding, and this is only for addition, okay, so be careful with subtraction. So if you start with 30% and you add 10%, your final product has to have a percentage between these two. So at the highest level it would be 30%, at the lowest level it would be 10%, or any percentage between them, but not higher than 30 or smaller than 10. All right, so it's not possible to number 6. All right, so I hope this has helped. Let me know if you have any questions on chemical mixture problems.